From SMK TinkerCAD. In today's video, I'll be showing you how to create obstacle avoidance car. I call it Octobot. So Octobot is going to move around randomly and then at the same time avoid any obstacles that's around it. So that's pretty much about it. Let's get started. Okay, so before we continue, I'm going to first explain what I'll be doing next. So I'm going to break the build into two main modules. So we're going to have our obstacle avoidance as the input module, and our second module is our driving module act as the output module. So for the obstacle avoidance, we're going to have three ultrasonic sensors for left, right, and right. So this sensor is going to detect distance reading and then send all this reading back to Arduino for processing. And then after processing, Arduino will control the output driving module. And our driving module main thing is just to move the car around so we can avoid obstacles. So for driving module, we're going to look into two styles of driving. The first style is what I call steering style. So steering style is exactly like how a real car is. Okay, we're going to have the rear motor or the back motor, where both motor rotates in the same direction. Okay, so if it's rotating in forward, both are going to rotate in forward. If it's rotating in reverse, both are going to rotate in reverse. But the main component that's going to be controlling the directions of the moving car is the steering. So we have the steering where we can steer towards left or steer towards right, so to change the direction of the moving car. Okay, so in this case, same thing. We're going to have two DC gear motor where both of them are going to rotate in the same direction. Okay, so if I'm rotating towards left, forward, then both rotate forward. If I'm rotating reverse, both reverse. And we have to control direction, we have servo to act as a steering. So servo turn to a certain angle or certain rate to change the direction of the moving car. For the second style is what we call differential drive. So differential drive, the rough idea of it is that we use the difference in directions of our wheel rotation to produce angular rotations, angular movements. So what it does is that these motors on each side can be controlled differently, so we can control the directions. Both of them don't have to move in the same direction. Okay, so let's say my left motor, now instead of left and right both move in the same direction, let's say forward, I can now make my left motor to move forward and my right motor to reverse. So what I'm going to have is that I'm going to produce an angular movement where my car can now turn toward right. Okay, so now instead of having to use another component like servo or steering, so I can just use motor to turn the direction of my car. Okay, so that's the rough idea about differential drive. In our main driving module, we're going to be using both of them, but mainly we're going to use steering style. Okay, we're going to use steering style, but there's one small part where we're going to be using differential drive idea, where we're going to talk about this further later on. Okay, so next we're going to look into the 5 scenarios that we want Octobot to achieve for this project. Okay, so the first scenario is that when there is no obstacles in front, what we're going to Octobot to do is to move forward at the maximum speed. Okay, that's the first scenario. And the second scenario is there is obstacles in front. So what we're going to do is that Octobot, the front detector, is going to detect the presence of the obstacle in front, and then what it's going to do is it's going to stop for a few seconds, reverse for a few seconds, and this time it has to decide whether to turn left or to turn right. Okay, so for that we're going to ask the left and right detector to check presence of obstacles on the left and on the right. Okay, so now comes in the third scenario. So we're going to combine second scenario and third scenario together later on. So third scenario is that there is obstacles on the left, no obstacles on the right. So what we're going to want is the car to steer towards the right. So we're just going to turn right. Okay, so now when we combine scenario 2 and 3 together, what we're going to see is that the front detector is going to detect front obstacle. It's going to stop for a few seconds, reverse for a few seconds, and then check left and check right. Comes in the third scenario, obstacle is on the left, no obstacle on the right. So I'm going to steer and turn towards right. Okay, so now let's look at the fourth scenario is that let's say now the obstacle is not on the left, now the obstacle is on the right. Okay, so right has obstacle, left has no obstacle. So what I'm going to do is to steer towards left and turn left. Okay, so let's say we combine 2 and 4. So what we're going to see is front detector sees obstacles in front, stop the car for a few seconds, reverse for a few seconds, check left and right, and comes in fourth scenario, obstacle is on the right, no obstacle on the left, steer towards left, turn left. Okay, the fifth scenario is that after checking left, what we get is left and right both have obstacle. So what we're going to be doing is to stop the car again, and then reverse the car again, and this time it's going to make a U-turn. Okay, so after U-turn, our car is going to face the opposite direction. Okay, so when we combine scenario 2 and 5, what we're going to see is front detector it's going to stop for the first time, reverse for the first time, check left and right. So fifth scenario, left and right has obstacle, so it's going to stop for the second time, reverse for the second time, and make a U-turn. Okay, so that's the 5 scenarios. And for scenario 1 to scenario 4, we're going to be using steering style for the driving module. Okay, so whether to steer towards left, steer towards right, or steer back to the center position. So all these are going to be using steering style. But the fifth scenario, when we are making a U-turn, we are going to be using differential drive. Okay, so why is that? Is because when we are making a U-turn, we did not check if there is obstacle on left or right. So there are chances of it having obstacle. Okay, so if we were to use the steering style, what's going to happen is that steering style requires a very big amount of turning radius. So this turning radius is going to increase the chances of hitting the obstacles if present, okay, when making the U-turn. So we want to reduce the risk of hitting obstacle if there is, okay. So if we were to use differential drive now, it has the capability of rotating the car at its own position, or I can say at the very least turning radius, okay, so almost at its own position, okay. So this helps to reduce the risk of hitting any obstacles around it if there is that. Okay, So that's the reason we are using differential drive for the last U-turn part. Okay, so that's the 5 scenarios. So now we're going to start by building our circuit. So we're going to start with our driving module. So for that, we're going to need Arduino Uno, and then motor drivers L293D, 2DC gear motor, 1 servo, and 1 external power supply 9 volt. So motor driver is used to control the activation and the speed of our DC gear motor. So it's important because we are using differential drive. We're going to need to control direction. So motor driver is in charge of doing that. Okay, so I'm going to need servo as the steering. And we are using 9 volt because we need 9 volt to power up the motor, so the motor have enough power to rotate. 5 volt from Arduino isn't sufficient enough. Okay, so that's the components we need for our motor driver. Next, we move on to our optical avoidance module. So we'll need 3 ultrasonic sensors. Make sure you're using HCSR04. Okay, so I'm going to copy paste that, rotate it. Okay, so these are all the parts that we need. So we're going to start by wiring it up. So I'm going to connect wiring up this motor driver first. So we're going to connect ground to ground. Okay, so we want the ground to ground, and then there's a ground here, it's bottom ground. We're going to connect it back to the ground on the negative terminal on our power supply, 9 volt. Okay, then make sure you're connecting power 2 to 9 volt positive terminal. Okay, and then we have power 1 here, so we want to connect power 1 back to Arduino, 5 volt. So this 5 volt will be used to power up the IC chip for this motor driver. Then connect the GND. So we need GND from Arduino to okay, next we have enable 1 and enable 1, 2, 3, 4. So enable 1, 2, we're going to connect it to pin 6, PWM6, PWM5 to enable 3, 4. So enable pins are used to control the speed or the activations of the for this motors. Okay, so I'm going to connect that. Okay, next we're going to power up input 1, input 2, input 3, input 4. So we're going to connect input 1 to digital 8, digital 7, input 2, digital 4, input 4, digital 3, 4, input 3. Okay, next we're going to connect output 1 and output 2 to our left motor, or right motor 1, input 3 and 4 to our right motor, motor 2. Okay, next we connect our steering or servo, so we're going to connect the signal cable to pin 9. We'll cover the green, and then we're going to connect GND to the negative, or the GND on the servo. Okay, for 5 volt, we're going to power up the VCC on the servo. Okay, so we are done for our driving module. Next we move on to our input module. So okay, input module, we're going to need ultrasonic sensors. So first time we're going to power up all of this power, this VCC to VCC, and then to 5 volt and ground to ground. Okay, so I'm going to power up, how I'm going to power up is just I'm going to connect all these VCCs together. So and then one of the VCC will be connected to 5 volt. So what am I doing here is actually just using one 5 volt to power up everyone. So I don't have to drag so many cables to all these components. I can just make all them to be connected to one main cable that is going to be connecting back to Arduino. Okay, and for GND, same thing. I'm also going to be doing the same thing. I'm going to connect all GND together. Okay, so what's happening here is that I'm going to get a main 5 volt here supplied to this VCC on this module. So all VCC that is connected to this module will also get this 5 volt. And same for this GND. But if you do prefer this method, you can also directly just connect all this VCC one by one to the 5 volt. Not a big difference. It's doing the same thing. And also you want to use breadboard, you can go ahead and use breadboard. I'm not a breadboard kind of person, so I'm not using one. Okay, so now we have powered up all our HCSR04. We're going to connect this trigger and echo pins. So for this right detector, the right HCSR04, I'm going to connect trigger to pin analog 0 and echo to pin analog 1. In case you're wondering why did I connect it to analog pin and not digital pin, because I don't have enough digital pins there. So I'm just going to connect it to analog pin. It doesn't affect much because my main point is just going to receive the signal. So it doesn't really matter if I want analog or digital. Okay, so next we connect this front detector. So we're going to connect trigger to pin 11 and echo to pin 10. Okay, so for last one, this is the left detector, so I'm going to connect trigger to pin 13, echo to pin 12. Okay, so here's our complete circuit. As you can see, we have our complete circuit. So this is how it looks like. Okay, so now for the fun part, we're gonna look at coding. So first time, I'm gonna create 3 variables. I'm gonna call it front disk, left disk, and right disk. So each of this is gonna be used to store the ACSR04's reading for each side. Okay, so first time, I'm gonna set my initial state for servo or our steering to be looking at the center position forward. So I'm gonna put 90 degree for my case is forward, and then 9. Okay, I'm gonna give it a short delay, about 1 second, so that you have enough time to position itself. And then I'm gonna ask the ultrasonic sensor to be reading the front detector's ultrasonic sensor to give our reading, to read our ultrasonic sensor. So front detector trigger is on pin 11, echo is on pin 10. So now after reading our ultrasonic sensor, we need to check. So we're going to check if it's more than or less than 20. So I'm going to use this mathematics to check. So I'm going to first check scenario 1, which is the front detector is more than 20. That means there is no obstacles in front. So we're going to move forward. So to move forward, I'm going to first put rotation saying that we're moving forward. Okay. And I'm going to ask serial monitor to print our state of motion, which is forward. So this is going to be very useful later when we are running simulator, so we can keep track of what's the state of motion for our robot. Okay, so to move forward, so remember we are still using steering style, so we're going to use servo to rotate towards the direction that we want. Okay, so for this case, we're going to want our servo to be rotating towards the center position, which is forward, 90 degree. And I'm going to give it a short delay, about 1 second, so it has enough time to position itself. And then now we can already rotate towards the direction that we want, but we still cannot move. So to move or to make the rotation, so we're going to use this back wheel. Okay, so for that, I'm going to use 2 of this block, which is used to control the speed of the motor, and then 4 of this block to control the wheel rotation for our motor. So we're going to want it to move at maximum speed, so that will be 255. You can put any number in the range of 0 to 255, but I want it to move at maximum speed, so that will be 255. And then our speed is controlled by enable pin, enable 1, 2, 3, 4. So for left motor is controlled by enable 1, 2 on PWM6 and PWM4 for enable 3, 4 right motor. Okay, so we want both of the back wheel to be rotating forward. So forward for left motor is pin 8 and right motor is pin 4 for forward. Set it to high, and then we don't want the wheel to be rotating in reverse, so we're going to set pin 7 for left motor reverse to low, and then we're going to set the reverse state on pin 3 for right motor to low. So we switch off the reverse state for both left and right motor. Okay, so else, that means it's the second scenario. So second scenario, the front detector detects, and then we're going to stop for a few seconds, reverse for a few seconds, and then we'll check left and check right. Okay, so for stop, I'm just going to duplicate this, bring that down. Oops, bring that to else. Okay, so we're going to label 1 stop, okay, because we have 2 times of stopping. So 1 indicates it's our first time stopping, so your monitor print 1. For second time stopping would be in scenario 5. Okay, so for stop, I don't need this, I'm going to delete that, edit that. Okay, so for stop, we want everything to be off, no speed at all, so 0, 0, and we don't want it to be rotating either forward or rotating in reverse, so everything would be low. Okay, so I'm going to stop about 2 seconds. If you want it to be longer, you can set it to any number you want. Okay, for my case, I want to stop for 2 seconds. After stopping, we're going to need to reverse. So I'm duplicating this, putting here. I'm going to label 1 reverse because it's our first time reversing. Okay, and then serial monitor print 1 reverse. Okay, so to reverse, I'm going to reverse at a low speed. You don't want to reverse at a rate of high speed because chances of you hitting objects at the back if there's any. So I'm going to reverse at a low speed, about half the speed, which is 127. You can put any number you want, but it's better to be low speed. Okay, so to reverse for left motor is on pin 7, so I'm going to activate that. For reverse for right motor is pin 3, so I'm going to set that to high. So we are not moving forward, so I'm going to set that to low. And I'm reversing for 2 seconds. Okay, so after reversing, we're going to check left and right detector. So I'm going to use 2 of this. So I'm going to check for left and check for right. Okay, so for our left detector, trigger is on pin 13, echo is on pin 12. For right detector, echo is on pin, trigger is on pin analog 0, and echo is on analog 1. Okay, so after reading, we're going to need to check, so I'm going to use this control if then else. So this time we're going to check if both left and right, both left and right. So this is the third scenario. We're going to check if left is less than 20, that means there is obstacles on the left, and there is no obstacles on the right, which is right is more than 20. Okay, so left is less than 20. There is obstacle, right is more than 20, no obstacle. More than 20. Okay, no obstacle, so we're going to turn right. So I'm just going to duplicate the forward part. Duplicate, bring it down. So we are still using steering, so we're going to use steering to steer towards right. Okay, so I'm going to print this is right because we are turning right. Now serial monitor to print right. Okay, so use steering, so right is 0 degrees, so I'm going to ask the servo to turn to 0 degree. Okay, so we're going to wait 1 second. For turning, we're going to turn at low speed, same concept with reverse. Okay, so I'm going to set that to half the speed, is 127. And then our back wheel is still rotating in forward motion. Okay, so nothing to be disturbed here. I'm going to ask it to turn right for maybe about 2 seconds. Okay, 2 seconds. And then after that, else comes in the fourth scenario, which is now the obstacles not on the left, the obstacles on the right. So we're going to need to steer or turn left. Okay, so for that, I'm going to just duplicate this entire block, duplicate it, turn it down. the else. So scenario 4, else, left distance is more than 20, no obstacles on the left, and right has obstacle which is less than 20. Okay, so we're gonna turn left, gonna comment that to left, serial monitor print turning left. Okay, so we are using steering now, so we're gonna ask our servo to turn towards left, which is 180 for my case. Okay, so we'll wait 1 second and then we'll wheel moving forward at half the speed. Okay, 1 to 7. Okay, I'm gonna turn left for about 2 seconds. Else comes in the fifth scenario, which is after checking left and right both are being blocked. So what I'm gonna do is we're gonna stop for a second time and then reverse for the second time and make a U-turn. Okay, so for first stop, we're gonna just duplicate the stop that we did earlier, bring it all the way down to else. Okay, it's gonna duplicate everything, so we're just gonna remove those that we don't need later on. Okay, bring it to else. Okay, so starting from this pin, we don't need it, so I'm gonna put it to the bin. Okay, so this time is our second time stopping, so I'm gonna label 2 stop. Gonna ask your monitor to print 2 stop. Okay, so for stop, same thing, we want everything to be low, everything to be off. No speed, not moving forward, not moving in reverse. We'll stop for 2 seconds, and then we're gonna start reversing. So reverse, this is our second time reverse. We're gonna ask serial monitor to print to reverse. Okay, so we are reversing at half the speed. To reverse on left motor pin 7, to reverse on right motor pin 3. Okay, so we're gonna reverse for 2 seconds. So after reversing, we're gonna need to U-turn. Make the U-turn, we're gonna use differential drive height here. So we're gonna want our left motor to be moving forward and our right motor to be moving reverse, so we can get the turning rotation. Okay, so get our U-turn. So for that, we're just gonna duplicate this block, bring it down here, and I'm gonna say I'm U-turning, so U-turn. Now serial monitor to print U-turn. Okay, we're gonna talk about the speed later on. So to U-turn, we're gonna ask our left motor to move forward, right? So forward for left motor is pin 8, I want to set that to high. And our right motor, we want it to reverse, which is on pin 3, so set that to high. The rest we'll set that to off, okay, which is low. Okay, so we're gonna U-turn about 3 seconds for my case. I'm gonna use 3 seconds for the example. So if your robot, when you're building a real one, if it takes more than 3 seconds, maybe it takes 5 seconds to make a complete U-turn, then you want to set that to 5. You can play along with these parameters. Okay, so for the speed, you can set it to high speed, you can set it to low speed, half the speed. Okay, so but what I want is that I want my left motor to rotate at a greater speed, at a higher speed compared to the right motor, which is in reverse. Okay, so this greater speed on the left and lower speed on the right will help me to rotate it even faster, where it helps me to reduce the turning radius even more. So for that, I want to achieve that objective, so I'm going to ask my left motor to rotate at a greater speed, about 200, and I'm going to ask my right motor to rotate at a slightly lower speed, which is about 150. Okay, so if you don't want, you can set it to the same speed if you want to. You can play along with these parameters and see how it works. Okay, so this is our code. I'm going to start simulation. Open up a serial monitor. Okay, you see the initial state, it turns to a center position, so steering is looking forward. So now this is scenario 1 when there is no obstacle in front, it's more than 20, so it's moving forward. Positive RPM with maximum speed is to 31 RPM now. Okay, so now we're going to look at scenario 2, which is there is obstacle in front. It's going to stop for first time, reverse for first time, and then check left, check right. So we're going to combine 2 and 3, scenario 2 and 3. So after checking, scenario 3 is that there's obstacles on the left, no obstacles on the right, so we're going to steer and turn right. Okay, so I'm going to make that scenario 3 first, which is left has obstacle, less than 20, right has no obstacle, so it's more than 20. Okay, from program we know that it's gonna first check for this front detector, and after that only check for the left and right detector. Okay, so my hands wouldn't be fast enough, so we're gonna make that scenario 3 first. Okay, so we're gonna look at the second scenario, less than 20. So it's gonna make the first stop 0 RPM. It's gonna reverse at half the speed, so negative RPM at about 117 RPM now. Okay, and then after checking, it's gonna check third scenario. It's gonna steer towards left, turn right. Sorry, steer towards right. And then you see both are moving positive RPM at half the speed, so 117 now. Okay, so that would be scenario 2 with scenario 3 combined. Okay, now we look at scenario 2 combined with scenario 4. Okay, so scenario 2 and 4 would be after checking. Now the obstacle is not on the left, it's obstacles on the right. So we're gonna steer and turn left. Okay, so for that I'm gonna make that scenario. So left has no obstacle, right has obstacle, so less than 20. Okay, so I'm gonna make this scenario 2 less than 20. So it's gonna make the first stop 0 RPM, first reverse negative RPM at half the speed, 117 RPM now. And then after checking, it's gonna comes in first scenario, it's gonna steer and turn left. So both are moving forward at half the speed. Okay, so that would be scenario 2 combined with scenario 4. Okay, so now we look at scenario 2 and 5. Okay, where after checking both left and right is being blocked. So we're gonna make our second stop and then second reverse and then make a U-turn. Okay, so I'm gonna make that scenario. So this is less than 20. This is gonna be less than 20. Okay, so comes in our second scenario, less than 20. Make my first stop 0 RPM. first reverse, negative RPM at half the speed. Okay, and then check left, check right, and then comes in my fifth scenario. So second stop, second reverse, and then it's going to make a U-turn. So U-turn, we see 183 RPM, positive RPM moving forward at greater speed, and this is negative 130 plus RPM. So it's moving in reverse with a lower speed. Okay, so that is what we'll get. This was moving forward, this is going reverse, so we get the U-turn position. Okay, so that is all our 5 scenarios. So hope you get it done, and thank you for watching.